This is Unit 3 Triangles, Lesson 3.4, Constructions and Triangle Guts. Taking a look here, don't forget a parent-guardian sign-off. I want you to go ahead and skip the review page today. Skip the review page. It got out of order accidentally. So you're going to go straight to this page. So today we're going to talk about triangle guts. The whole reason why I say the word guts is slang for our insides, our innards. So we're going to be talking about different kinds of segments that are on the inside or the inward part of a triangle. There's going to be lots of new terms today, so watch out for it. 1, say these words out loud with me. Median. Centroid, altitude, orthocenter, perpendicular bisector, circumcenter, angle bisector, incenter, vertex. Lots of new words there. So I'm going to introduce you very simply to the first 4 triangle guts. Just copy this with a straight edge right now. A median goes from a vertex to the opposite midpoint. Notice the hatch marks. Vertex, opposite midpoint. Trace that. That is a median. Think midpoint. Median. An altitude starts from a vertex and creates a right angle with the opposite side. That's an altitude. A perpendicular bisector. Trace one side, just trace that side. A perpendicular bisector is perpendicular to the side and cuts it in half. It does not necessarily go through the vertex. So there would be the midpoint. And then we're going to trace a segment that is perpendicular to that side and goes through that midpoint. That's called a perpendicular bisector. Last one, I'd like you to trace an angle. And I'd like you to sweep that angle. Now eyeball what looks like the middle of that angle. Now we're going to draw from that vertex bisector. An angle bisectors always take it across through the opposite side. And the reason is, I do not want your eyeballs focused on the side. Go through the side. That is an angle bisector. Your eye's focus is back here on the angle. So what I recommend you do right now is take a moment and talk yourselves through what is the definition of each of these very quickly. Pause the video, talk it through, restart. Welcome back. Let's look at these in greater detail. A median. A median is a segment which connects vertex to the opposite midpoint. Vertex to the opposite midpoint. We're going to draw all 3 medians right now, all 3. Ready? Eyeball that midpoint. Hatch mark. Trace this side, eyeball the midpoint, hatch mark. It's your second midpoint. Physically trace this side, eyeball the midpoint, it's your third one. Now we're going to trace 3 medians. Vertex, opposite midpoint. That's a median. Let's do another one. Vertex, opposite midpoint. Let's try another one. Vertex, opposite midpoint. The 3 medians cross at a certain point. That point is called a centroid. The way that I remember this is that the medians go with the centroid, I think MC, like MC Hammer, the rapper. MC. Median goes with the centroid. The intersection of the medians is a centroid. An altitude is a segment which connects a vertex to opposite side at a right angle. You're going to need a straight edge for this. Ready? We're going to draw 3. Darken that vertex. You're going to line up a straight edge, and you're going to make an altitude go straight to the opposite side at a right angle. Go through the side. That's an altitude. Let me switch colors so it's easy to see. Let's go this way. Vertex, and we're going to go at a right angle to this opposite side. Make sure it's at a right angle, so get your straight edge out. And you're shooting to make a right angle. Try another one. There's your vertex. Here's your side. Our goal is to make a right angle going through that vertex. All 3 of these are altitudes. The altitudes are going to cross at a certain point called the orthocenter. Orthocenter. Think AO. AO. The altitudes cross at the orthocenter. Let's talk a little bit more about altitudes because they're a little unusual. Taking a look about the altitudes when you have different kinds of triangles. When you have an acute triangle, let's just quickly draw all 3 altitudes. Corner, right angle. Corner, and you're shooting for eyeball a right angle to the opposite side. Right angle. Corner, right angle. Where they cross is the orthocenter. There's an example right here. When you have an acute triangle, all the altitudes are inside. All 3 of them are inside, and the orthocenter is also inside the triangle. The altitudes are inside, and the orthocenter is inside. Now in a right triangle, corner. You're going to go right angle. Remember, you're trying to eyeball it, corner, right angle, opposite side. That's one altitude. So 1 in a right triangle, 1 is inside. The other 2 altitudes, they're going to get a little strange here. Remember, it's all about corner and right angle. Well, if this is a right triangle, we already have a right angle right there. So to go corner, right angle, corner, right angle, you're actually on the side itself. Corner, right angle. So 2 of the altitudes are on the triangle, if it's a right triangle, and 1 is inside. And in this case, the orthocenter is on a triangle vertex. So an acute triangle, all 3 altitudes are in, and the orthocenter is also in. In a right triangle, 1 altitude is in, 2 are on, and the orthocenter is also on the vertex. Now, an obtuse triangle gets really strange. In an obtuse triangle, corner, right angle, there is still 1 altitude inside. But this one over here, we go corner, and you try to get a right angle with the opposite side. I'm just going to draw a bunch of examples. Do you see it's impossible to get a right angle and be either inside or on the triangle? It's impossible in that obtuse corner. So what we have to do is you extend a side, and corner, right angle, you have to make a right angle with the extended side. So 1 of your altitudes is outside. Let's come over here, see what we can do about this side over here. Corner. Again, we cannot get to the opposite side and make a right angle, so we have to trace and extend. And our 3rd altitude is also outside. So we have 1 in and 2 are outside. Outside. And if you look carefully, if we were to connect these and extend all 3 of these, eventually they intersect. We actually don't have enough space here. But you can see the illustration here. The orthocenter in this case is outside. The 3rd one is called the perpendicular bisector. Perpendicular bisector is a segment which is both perpendicular and bisects a side. Okay, warning, it does not necessarily go through the vertex. So let's trace this side, eyeball what looks like the middle, hatch mark. Now, draw a bisector at a right angle. That's a perpendicular bisector. Let's draw 2 more. Eyeball the middle, and you're shooting for a right angle. Your eyeballs are not on the corners there. This has nothing to do with the corners. It's all about cutting those sides in half at a right angle. Where those three perpendicular bisectors meet, that has a name. It's called the circumcenter. You're not going to understand the significance of that until class time, when we start using a compass in class to do construction. So the three perpendicular bisectors meet at the circumcenter. Did I remember that? Perpendicular bisectors, circumcenter, a PC computer. Last one is an angle bisector. Last of our four triangle guts. An angle bisector is a segment which bisects the corner angles. So once again, your eyeballs are on the angle itself. So just let's sweep one angle, eyeball what looks like the middle, and now you're going to draw a segment using a straight edge, take it through the opposite side so that you're focused to look at the angle, not on the side. That's one angle bisector. Sweep, eyeball what looks like the middle. Starting from the vertex, going through. That's an angle bisector. Let's try a third one. Sweep, middle. And these are going to intersect at what's called the in center, the in center. Where I remember that is altitudes cross at the in center, AI like artificial intelligence. Now there's a specific quality about the centroid that we're going to go over here. A specific quality about the centroid. Ready? Say. We're going to mark the midpoint of LM point R. The first thing we're going to do, LM, eyeball what looks like the middle, hatch mark, that's point R. Now we're going to mark the midpoint of MN, S. So eyeball the middle, hatch marks, it's a midpoint. We're going to call that S. Now we're going to find the midpoint of NL, eyeball what looks like the middle. We're going to call that T. Now, very carefully, let's draw our three centroids. Vertex to midpoint. Use a straight edge, please. That's a median. Vertex to midpoint. Vertex to midpoint. Vertex to midpoint. They cross at the centroid. Now, What I'd like you to do is I'd like you to finger pinch, please. Finger pinch the centroid to R and compare that distance from here to here. And I'd like you to finger pinch from here to here and compare that distance going this way. Finger pinch again, this distance, and compare it there. You're going to notice a property. You notice it's an x to x relationship all the way around. So when this is called the centroid center equation. When you have a median which connects vertex to opposite midpoint. Do that again. Midpoint, midpoint, midpoint. Connect them. Use a straight edge. Vertex to midpoint. Vertex to midpoint. Vertex to midpoint. Ready? They cross the centroid. This that red segment is half the length of the blue segment, or it takes two reds to get into the blue. Or you can say that pink segment is going to be half the length of the orange segment, or it takes two pinks to go into the orange. Or that blue segment is half of the light blue, or it takes two dark blues to go into the light blue. Once again, the relationship all the way around is an x to x relationship. So let's try this. Let's trace and see if we can't complete these sentences. So AG, trace it, A to G. Is going to be half, excuse me, 2 times of G to B. This is called a thing equation. You need to learn to think in terms of things. Let's try CG. CG is double the size of GF. Let's try this last one. EG is double the size of BG. So we see here that that's a thing equation. Learn to think in terms of things. Now we're going to use this thing equation to solve here. Ready? All three are medians. So let's just put our hatch marks in here. In this triangle. One hatch mark, two hatch mark, three hatch marks. Okay. We are told that J to N is 8. And we want to find N to M. Let's write our thing equation first, even though this is an easy one. We know that Jn equals 2 of NMs because of that centroid there. So now we watch. This is 8 equals 2, and we're going to replace this just with an x. And now we simply solve for x. And we know that n to n is 4. Now that was a simple one. The reason why I'm making you use a simple one is because I want you to get in the habit of making a thing equation before you do your algebra. Let's try another one. We are told here that h all the way to k, the whole thing is 24. And we are being asked to find h to n. Let's make our thing equations first. Hn equals 2 of the nk's. We also know this is true, that h all the way to k is equal to the blue Hn plus the red Nk. Problem is we don't have Hn here. But we do know that Hn can be replaced with 2 Nk. So look what we can do here. We can say that 24 equals 2 Nks plus Nks. Now let me just replace those with x's to make it easier. 24 equals 2x plus x. X equals 8. That means n to k is 8. And h to n, which is double, is 16. And then we check 16 plus 8 does that up to 24. Right here, F is a centroid. We're going to do one more with algebra here. It says we want to find x if w to k, which is the whole thing, is x plus 3. And we are given that f to k, which is this guy right here, is negative 7 plus x. We're supposed to solve. Let's do our thing equation first. Our thing equation says wk is equal to f to k plus f to w, which we don't have. But let's see what we can do there. Wk is x plus 3. We already have f to k, which is negative 7 plus x. Plus, now we know f to w is double this, so we're going to do 2. Now we simply solve. Try to do your own algebra here and then look up what you've done. Now let's see if this works. 12 plus 3 So x equals 12. Students, this is really important. We have a lot of information here. Set your timer for 2 minutes on your phone. Go back and re-explain all these concepts to yourself in about 2 minutes. Very important you go over everything.